Hello, my name is Joshua Stevenson, and this poster presents my proposed dissertation project for the MEng Cybersecurity and Digital Forensics course. My project focuses on the design and implementation of an automated forensic tool that will be used for the extraction and analyzing browser artifacts that were generated during a private browser session, so using for example, incognito mode and things like that. So, onto the rationale of my poster. So, private browsing is widely promoted as a mode on browsers that prevents tracing the user and prevents any data from being stored on the device, so your search history, things like that. However, recent studies such as the Do Private and Portable Web Browsers Leave Incriminating Evidence by Ohana and Shashidar in 2013 have proved that private browser sessions can sometimes leave residual artifacts on the device. This means that the users might be unaware of the actual level of privacy that these supposed private browsers are promoting, so what bits of the data are actually being recorded without them knowing. So there are existing tools like autopsy and volatility that are able to go and retrieve this data. However, they rely on the manual extraction of this data, and this could be quite time consuming for a forensic investigator during a investigation. So this project is aiming to make an automated tool, as there is currently no automated open source tool to do this on the market from my research. So, and the idea of this would be to help to speed up the work of a forensic investigator to allow them more time to, well, focus on other areas of the investigation that might be more important potentially, or just more relevant. So, moving on to the aims and objectives. The overall aim of this project is to design, create, and test an automated forensic tool that can be used for the capturing and analysis of any browser artifacts that can be generated through private browser sessions. And to do this, I have four key objectives. So, firstly, is to define a modular architecture for the forensic tool. So, the different parts of the tool can be modified or updated individually. Secondly, would be to implement a prototype of this tool, so basically make a tool that is actually able to perform the function that I am set out to doing, so the automated analysis of the artifacts. The third of these objectives is to actually analyze these artifacts and compare the results between different browsers. So, is the tool able to identify what browser is being used? Are there differences between what data it can get from each browser? Do some browsers take longer to extract? Anything along those lines, basically. And then finally would be evaluating the tool's accuracy and its limitations and performance, so comparing it against the manual tools, as previously mentioned, autopsy and volatility, to see is this tool actually faster and is it saving any time? And is it picking up less or more data from these artifacts? So could there be stuff that would be missed by a manual investigation that the automated tool would be picking up on, as it does not fall to suspect to human error? So, and then directing you to the methodologies section of this poster. So, this project is designed, well, it's a product based project, and it is using the design science research methodology, which I will touch on more later as I have a diagram of it on the poster. Then the data collection will be done via private browser sessions within a Windows 11 VM to prevent any external contamination of the sessions, as well as the automated artifact extraction will look at things such as the cache files and things like that, seeing what it can actually extract. The implementation of this tool will be a Python-based modules for the final product of the tool, as Python is the language that I have the most experience programming in. And then the utilization of version-controlled VM snapshots will be done for consistency of the project and to make save states of the machine, so to make sure these results can be repeated and it's not a one-off occurrence. And then finally, the evaluation method. So the tool will be compared results against the manual analysis with autopsy and volatility. So we'll be looking at metrics such as the artifact count, processing time, what different types of data have been collected, and then these experiments will be also repeated to ensure that this data is, well, set in stone. It's not a one-off occurrence or anything that could potentially change what data is being extracted. It's making sure it's solid and can be tested against. And then on next to the ethical considerations, so we have only non-personal data is being used in this experiment, so only searches such as how does a duck fly, something basic like that, will be used just to make sure there's none of my personal data going into this experiment. Any artifacts recovered will be handled in accordance with the ACPO guidelines, which are the guidelines used by many forensic investigations. There will be no access of websites during the investigation that may be considered illegal or harmful, so anything on the deep web or dark web, anything that falls under that umbrella of classification, basically. And then the final tool will be designed purely for forensic use and only tested within restricted testing environments, so on these virtual machines is where it would be tested. Then finally, onto, well, not quite finally, but the risks and mitigations. So we have the risk of data contamination, which will be mitigated by the VM snapshots mentioned previously, as well as a consistent and mapped out testing method. So each browser will be tested the same way with the same search queries, for example, and things like that. And each browser will have all of the queries that all the others have using, so there'll be no differences in what data is being given. The only differences will, in theory, be what data is recovered by the tool. Incomplete / inconsistent artifact extraction. So, for example, if an artifact looks like it is missing data, so for example, oh, this artifact doesn't know what date it was created on, this will be checked with a manual tool, so autopsy or volatility, and if that is also missing that piece of information, then it can be concluded that the automated tool isn't missing the information just doesn't exist. So double checking to make sure it's not just missing verification data. Sorry. Then we have the tool failure from the browser version. So an older or an updated browser. So the way this can be circumvented is via the modular design. So say a browser gets updated and the tool no longer is compatible with it. If it is purely the extraction of the artifacts that is no longer working, which would likely be the case, that module of the tool itself can be targeted to be updated without having to affect the tool in its entirety. So as long as the module is edited to have the same output standard, or like the way it's outputted, the rest of the tool should function correctly once that has been updated to handle the new browser updates. And then finally, we have the secure handling of the artifact data. So that will be done by using encrypted storage directories, as well as any experimental data being deleted after the analysis has been performed. So, for example, any cookies that could be left over from any previous browser sessions will be removed, so that it's not tampering with any new data that might be produced from the browser. And then finally, we have the graphics on this poster. So first of all, we have a visual representation of the DSRM methodology. So you define the problem, you can go into the problem-centered initiation and loop around that. And then you define objectives of the solution, design and development, demonstration, evaluation, and communication. And then each of these points can sort of loop back, which is very good for designing a product, as it allows you to design, test, and repeat over and over until you have your finished design. And then we also have the mock results table, so we've got the browser, has it obtained any cache artifacts, has it obtained cookies, has it got any URLs in the RAM, and how long it's taken to extract. So this isn't actual data, this is just an example. And with that, that is my poster. So thank you very much, and I look forward to hearing any feedback.